All right, guys. So the recording has started. Thank you for joining the session. Uh, yeah, so we're actually discussing the firewall policies. Let me share my screen. So this is the whole topology that we actually use to sort of demonstrate how the firewall policies actually work in the Fortigate. We have seen quite a few things. We're just trying to make sure that we give access to this particular guy to the internet because he belongs to the IT, right? And uh, we did configure the L2 VLAN. So when you talk about the L2, it's again sort of the network segmentation. So you're just trying to segment this particular switch into multiple switches with the help of VLANs. That is the whole concept of VLANs. And then you said that, okay, I want to go beyond this, right? So you came to the firewall and defined an ACL, right? And ACL is something that is going to actually work on the network layer, right? And the VLAN that you created here was actually working on uh, the data link layer, right? Which is the L2. So when you actually came here on the FortiGate side, and then you said, uh, now that I'm on the firewall and you call firewall as an L7 device, so you can basically go beyond the layer 3 as well. So you added layer 4, what is sort of called the ports, right? And then firewall said that I'm a stateful firewall, so I'm actually going to track the sessions, right? And we're going to see in the future how you're going to include the authentication as well. So this particular user, whenever he needs to go to the internet, he'll have to prove himself with the help of the corresponding identities. And when you say proving an identity, it means the authentication, right? Let me just bring the Epic pen. So when this guy is actually going to provide the credentials, the username and password to this firewall, it's actually going to sort of authenticate that particular user. So you're just moving beyond the layers now. You're going to move beyond uh, the layer 4, and then you basically reach to the session layer, right? And that's why you basically add the another layer of security in accordance with the OSI model, right? And then at some point in future, we're going to see this firewall is capable of doing the SSL decryption, which means that whichever the SSL traffic that actually came from here, and SSL is nothing but the HTTPS traffic, right? Secured HTTP, right? It means nobody can actually see what this guy is actually generating, right? We're going to see in future that this firewall, if configured for the SSL decryption, you're going to go beyond the session layer, right? So the layer of security that you're adding here is data link layer with the help of VLANs, then the access control list, or which you actually call the firewall policy, which has source IP, destination IP, and the services. Serves are nothing but the ports, right? And that firewall policy basically includes your uh, security from layer 3 and layer 4, right? And then you want to go beyond that. So you add the sessions, the stateful capability of this firewall, which is your session layer, right? And then you want to go beyond that. So at the top, which is the application layer, which is the layer 7, right? You can do the SSL decryption on this firewall, and then everything that this guy is actually generating, right? Not 100%, but at least 90% of that will be visible for this firewall, right? So that is the whole point of the NGFW. So let's just start with today. Control W. Let me check the IP address on this firewall. So admin 123. I'll check the IP address. I do diag IP address list. Okay, it's the same one. So I'm going to do HTTP, and this has to be 136.129. Admin 123. Let me check if the firewall policies are still there or not. So I say, don't show me this. Network interfaces. Me 1 second. Okay, sorry about that. So let me come to the firewall policy. So, all right, so there is nothing. So let's create the firewall policies here. I will call the IT guy internet access. Check if the source interface has to be IT. The outgoing interface has to be port 1 source. Or let's do it this way because we already have sort of explained the firewall policies based on the interface. And in our recent class, we also discussed that you can call multiple interfaces in a single policy, right? So today, what we are going to do is let's just discuss the concept of zones now. So what is a zone? See, the point here is if I go back to this particular lab, there are three people, which we say that these are three departments. One of the departments is IT, the other department is finance guy, and the other department is HR, right? Uh, this is a very basic picture of how the corporate office would look like. But if we just try to uh, zoom it in, right, there'll be a lot of PCs here which actually belong to IT. And likewise, we'll have a lot of PCs here which actually belong to finance, a lot of PCs here which actually belong to HR department, as in, right? Now, if I have a requirement where people tell me that this finance guy would need access to LinkedIn, and at the same time, this IT guy also needs access to the LinkedIn, right? Do I have to create the separate policies for them? The answer is no. I can create a single policy and then call multiple interfaces in that particular policy. I can call the IT, which is VLAN 10. I can call the this particular, which is VLAN 20. Right? I can call it in the policy, and then both of these can actually do the same thing, which are the stuff they actually want to do. But that is one way of doing it. The other way is if these two actually have a common requirement, these two actually have a similarity, right? I can zone them. I can create a zone of these two guys, right? And then I can create zone-based policies on the firewall. So the whole point is, what is a zone? We go to the whiteboard, go to the. So when you talk about the zones on the firewall, zone zones in Fortigate, right? Zone is nothing but a group, in fact, a logical group. right, of a single interface or multiple interfaces, right? And the whole use case of why you will be basically calling multiple interfaces in a single zone is because they have some similarity. So there is like sort of an intersection between multiple departments. And when I say intersection, it's basically the basically from the use case point of view, right? It's more like the IT guys want to do this stuff, which is very similar to uh, the other department, right? Or one of the other cases would be that there are some of the people who are here in the IT department, right? They want to access something that's on the internet, and at the same time, you introduced a one more VLAN over here. So I'll just create one more VLAN. I'll just call one more PC over here, call it VPC. Go here, go to the switch. Let me see if the switch is containing all the configuration. Enable show INT stats. All right, it has everything. So what I'm gonna do here is I'm going to turn off the switch because I have to connect a cable with it. Now, let's assume this VPC is a brand new department which was introduced, right? And they're sort of doing a similar stuff which the IT people do, right? Now, one of the cases would be that you connect them to the same switches where the IT is connecting, right? But if you want to still have some sort of uh, segregation, a segmentation between IT and those people you just introduced in the network, right? I can just uh, make them a part of a different VLAN. So I want to configure this one over here. I say IP. I do show IP. There is no IP address on this. So give me an IP address 192, 168. Yeah, 5.1 slash 24. And then the gateway has to be 192, 168, 5.10. All right, so this is the IP address that I actually chosen for this one, and I'm gonna since I connected it on Ethernet 1/0, right? So let me choose a VLAN for it. 192, 168, 1 dot. Okay, it's 5.0 slash 24 PC. I can call this VLAN 50. Save this here. I come to the switch. I'll have to create an L2 VLAN over here. Show INT stats. It's connected on 1/0. So I say config t INT Ethernet 1/0. I want to put a description over here. It is what do I call it? Which department? I call it semi IT. And then VLAN 50 would be fine. Then switch port mode access, switch port access VLAN 50. Show INT stats. Show INT stats. So there you go. It's in the VLAN. So let me check if the VLAN is already there. So show VLAN 50 is already there. Now let's go ahead and go to the firewall and create a VLAN 50. So since I'm creating all these SVIs out of port 2, so I'll go to the port 2 here, right? I have 10, 20, 30 already created. I'll come here, I go to the interface. I call this semi IT. Create the same name over here. It's a VLAN. The interface that I'm actually getting it out of from is port 2. This is 50. And then the IP address is 192.168.50.10/24. That is the gateway that we just actually kept for the PC, right? And here you're going to put the ticket and date. Click on OK. Right. Now let's check if this guy would be able to ping the gateway. Mm, okay. We already have opened. Okay, it's here. We can do it from here. Show IP. If I want to ping 192.168.5.10. What did we keep here? Is it 50 or 5? Okay, has to be changed here. So it should be 5. We come back over here. There you go. So the gateway for this one is reachable. Now, the only point that I'm basically trying to explain here is that both of these departments have a similar requirement. They have a very uh, sort of similarity in between. So I want to logically group the VLAN 50 and the VLAN 10 on the firewall in a logical group, which I basically call zone, and then create the configurations based on the zones, right? So what I'm going to do here is I'll go to the firewall. I click on create new. I'm in the interfaces. I click on zone. I name this as IT global. So which are the departments basically fall in this global IT group, right? And need anything to be done on the firewall. As long as every department needs access to which other requirements are, right? I can call this zone on that in the firewall policy, right? So it's sort of uh, reducing a lot of manual configuration and repetitive configuration that I would actually have to do if I don't have zones, right? For example, if IT needs something to be done on the firewall, IT needs access to something. I just come on the firewall and create something for the IT, and then someone from the IT department comes, says that I'm a different VLAN. I get this different subnet. I'm not exactly what the firewall actually is containing regarding the IT, but I sort of have a similarity with that department. So I also need access to this uh, particular platform, right? So in that case, you will have to repeat the firewall rules, repeat the configurations, and to be uh, a lot of repetitive configurations actually. So for that reason, I'm just reducing all those things, and I come here on the firewall, I zone them. It's more like a bucket and put all those VLANs into this particular zone, and then create zone-based policies, right? So for me right now, IT is one of the guys who needs access, and then one more was semi-IT, right? I'm gonna put the ticket and date here. By the way, this is ticket number, right? So I click on OK, right? Now you could see that my zone is here. It's showing up here, right? Focus on my cursor, and it contains VLAN 10 and semi-IT, which is nothing but VLAN 50, right? Now I can create the firewall policies. I call it IT access to internet, or maybe global IT. Now, incoming interface would be IT global, which is actually a zone now, It's not an interface anymore. If I just hover the cursor over this, it says that I'm an interface, I'm a logical interface and basically a zone, right? My link stats is up, which is the green sign over here. My type is zone. I'm not an interface, but I'm a zone, more like a bucket in which there are members. And currently I have VLAN 10 and semi-IT, which is the VLAN 50, right? And this is a description that's actually going to tell you what was the requirement, because the ticket always contains all those details, which actually can tell you the purpose of this particular change that we're just doing on this firewall. Now the outgoing interface is going to be port 1. Source has to be uh, I will just call here create. I want to do IT guy, and for that we have the IP address 192.168. What was the IP? 1.0 is a subnet here and 5.0. So this has to be 1.0/24. You're going to put the ticket and date here. I want to change the color as well. This is the IT guy, and then we have semi-IT guy. Maybe change the color to something different. 192.168.5.0/25. I'm just allowing the whole subnet here, not just a single PC. This is your ticket and date. Pick this one and then call this one over here as well. Destination for now is all. I want to give the full internet access. This is all, and this is your firewall action, which is accept. Inspection mode is flow based. We did discuss what is the difference between flow based and proxy based in our recent session. The NAT is the policy NAT that we're actually doing here is it's the source NAT already discussed. IP pool config, we're choosing the outgoing interface as this one. So it means the source, which is here, IT guy and semi-IT guy, they're actually going to get translated into this particular IP address, which is the outgoing interface. And for this particular policy, the outgoing interface is port 1. So whichever the IP is there for the port 1 will look like to be the IP addresses for these two guys when they actually talk to anything on it, anything on the internet, right? Now this is your security stack over here, the UTM stack, right? Which is actually going to do the UTM inspection for your policy, for your traffic. These are the logging options. So I'll just click on OK, right? Now a single policy is basically taking care of your two departments, the IT guy and the IT department and the semi-IT department, right? Both of these can actually go to the internet. Let's have a test now. If I do ping 1.1.1.1, so it's able to go to the internet. And if I go to this particular guy now, I want to cancel this one, go to the command prompt, IP config. All right, it is there. So 1.1.1.1. It's working perfectly fine. Now the point is, if there are two things which are in a single zone, right? So let me just try to demonstrate it here. So this is a zone, which is nothing but a bucket, right? I'm putting IT interface, which is VLAN 10, and I'm putting semi-IT, which is VLAN 50, right? I'm putting in this, and then it's not VLAN 10 anymore. It's not VLAN 50. It's a zone, right? I call this zone, what did I call it? Zone IT global, right? And now the policies are basically defined based on the zones, right? So this guy can go to the internet, right? But can this particular person talk to the uh, the semi-IT people? Does it even happen? If these two guys actually belong to the same zone, can they talk to each other by default? Let's check it out. So I don't have a policy here on this firewall which says that IT should talk to the semi-IT, right? But I know that both of these actually belong to the same bucket, right? They are here. This is VLAN 10. This is VLAN 50. They're just here, right? So if I come to the firewall now, go to the network, go to the interfaces. I want to check the configuration on this one. So it is the name of this particular zone is IT global, which we just kept it like this, right? It says block intrazone traffic, and by default it's on. It means anything that's happening within this zone, any interfaces which are actually part of the same zone, right? They cannot talk to each other. If you want to make sure that they talk to each other, you can just turn this option off here, click on OK, which means that you don't need a policy between uh, VLAN 50 and VLAN 10 on the firewall side, because of the zone that is actually created here on the firewall, right? They're part of the same zone. 50 and 10 are belong to the same zone, and you just said that within this zone, anyone who is member of this particular zone can talk to each other. We just turn this particular option here off, right? Now, will it be possible for this particular PC to talk to this particular guy? What do you think? Let's try that. So I was here. I want to ping 192.168.1.1. Works, right? So wait a second. Okay, it doesn't have to be this. Ping 192.168.5.1. So it works, right? The IP address of this particular PC, which is the IT guy, is 1.1. It's trying to reach out to the PC, which is 5.1, right? And it's working perfectly fine. So when you're creating a zone on the firewall, right? The idea is that you're putting multiple VLANs within that zone, and then it's sort of a logical group. And there you get to define whether you want to block the intrazone traffic. And intrazone basically means which are the members are part of the same zone. Ideally, by default, they won't be able to talk to each other because that's how the firewall is set up, right? And if you want to manipulate this behavior, you just have to go to that particular zone, right? Go to the zone here in the interfaces, open this one, and then you say, I don't want to block the intrazone traffic. So the moment you do that, any of the members that are actually here will be able to talk to each other, right? And that's what actually is happening over here, right? So this is the whole point of the concept of zones, right? And the concept of intrazone and interzone traffic. Now, here's the thing. What is difference between intrazone and interzone traffic? Let me just come here. Any guesses? What would be intrazone and interzone traffic? Intrazone means within the zone, right? So zone contains nothing but the interfaces. And when you're saying that within the zone, it means these interfaces can talk to each other or they cannot talk to each other. So the default behavior is intrazone is blocked, right? If you want to change it, you just have to manipulate the configuration, right? Now the interzone communication basically means communication between the zones, right? And this always is blocked, right? You would always need a firewall rule to allow communication between multiple zones. Always needs a firewall rule, right? The only difference here is that this is your default behavior in the intrazone, right? Which are the members are basically part of the superset, which you call the zone, right? They won't be able to talk to each other by default, but you can manipulate this within the same zone. But if you want to do the same thing over here, you want to make sure that multiple zones can talk to each other, you have to create a firewall policy, right? So let's just try to demonstrate this. Let me come over here, come back to the lab. So these two guys now, can I custom shape? I want to do a square circle. Has to be like this. So this is your zone, right? It is Zone IT Global. Now let's try to create one more zone. So I create a zone for the finance guy. I already said a zone is a logical group. It's a logical interface which contains one interface, which is the VLAN interface, or you call it as SVI, switch VLAN interface, or multiple interfaces, right? Which means that I can create a zone for the finance guy alone as well, right? So the finance VLAN, which is nothing but the VLAN 20, can also be created into sort of a zone. And then I can say that would this guy would be able to talk to this guy? The answer is no. And if you want to make sure that this particular zone should be able to talk to the zone uh, finance, or whichever we call it, right? We need to have a firewall policy. Let's just try to demonstrate that particular thing. So if I come to the interfaces, I come to create new, I come to zones, I name it zone finance. The interface for here is VLAN 20, which is the fin department. I'm gonna come here and I say ticket and date. The only reason why I kept doing this is because these two things are really important. Any time you're actually making change on the firewall, please make sure that these are very critical. And at the time of audit, if there is anything, auditing means that someone just comes and then says how you're actually protecting the data of the people and your data. If you're actually doing uh, all the things that actually are compliant to the security policies, right? So I'll just come here. I click on OK. I created a brand new zone. It contains the VLAN 20 now. I'll come here, go to the firewall policies. Now the whole point is I want to make sure that zone global ID should be able to talk to the zone, what do you call it? Zone finance, right? Let's just try to demonstrate that first. So zone IT has one of the PCs now, ping 192.168.2.1. I am on the IT PC, which is this one. I'm trying to reach out to the finance PC. Will I be able to do that? The answer is no, because it's getting blocked on the firewall. Let's just try to check on the firewall what exactly is happening with this traffic. So if I come here, I do diag, debug flow, filter, ADDR. I'm trying to reach out to 192.168.2.1. Is it? Yeah. Diag, debug flow trace start. It means how many number of packets you want to check the trace for, and then I do the debug flow show function name enable to check all the functions that are actually acting on the traffic, and then the debug enable. I'm going to come here and I try to repeat this, right? Let me just try to reach out to 2.1 now. So I could see 1.1 over here is trying to reach out to 2.1. It says allocate a new session, find a route, right? And then it says denied by a forward policy check, because there is no policy that would actually say allow IT to go to the zone finance, right? So we need a firewall policy for this one. So I'll come here. I will say IT global to finance. How many characters can I actually maximum put here? It's a very important question. I mean, I can just keep on writing here and then at some point it starts just telling me that this particular red sign means there's something error, some error is there, right? How many characters can I put here? 35. Just remember that. It might not be making a lot of sense right now, but when you actually start configuring things in the production, then a precise name actually makes a lot of sense. So I say global IT to finance, right? I come to the incoming interface. Now it's a zone-based architecture. So I come here, I say IT global will be able to talk to zone finance. Source interface has to be, okay, source has to be, where is our source? IT, okay, this is your IT. Destination is, I shouldn't have the finance here. So I create one. I call it finance department. So change. This is 192, 168. What is the subnet for this one? It's 2.1. So I call it 2.0/24 to give access to the whole subnet. This is your ticket and date. I click on OK. Services has to be all for now. And do I have to NAT it? A question to everyone here. Do I need to NAT it? Yeah. So it's an internal subnet trying to talk to an internal subnet. Do I need to NAT it? Can you guys hear me? Hello?
Hello.
I don't think so. It's necessary.
Correct. Yeah. So I don't
Let's
have
see.
to NAT it because the moment traffic reaches to the firewall, right, I can quickly demonstrate it out. So let me just come here. So there you go with the Epic pen. So the point here is that the source packet. What's wrong with this? Let's do it here. I want to close this. Come here. So the point here is the moment I leave from the source, my source here is the ITPC, right? The L3 information. The source IP, the destination IP, right? It is 192.168 1.1, trying to reach out to 192.168 2.1, right? This packet would go to the firewall, right? Now, firewall is a full-blown router, as we have already discussed. So what it is actually going to do is it learns the source and forwards based on destination. Now it's going to check this destination is there or not. So there are ARP entries, right, which this firewall learns from this particular guy over here, right, which is the Linux PC. So it knows that if I'm connected here, I do have the connected routes back to the 2.1. So for that reason, it doesn't have to NAT anything, right? And also when the traffic comes back and then it's more like a response comes from this particular PC, right? It goes to the firewall, right? And the firewall says that, okay, now the response is basically for the IT guy, right? And the again, same thing happens that it's actually going to forward the packet based on the destination. So the response is actually meant for the 192.168.1.1, right? 1.1 is directly connected to the firewall again, right? So with the help of connected routes, you're known to the sources and you're known to the destination. So for that reason, you don't have to NAT it. So I can turn this off, right? Security stack, we're going to pick it up when we discuss this. Logging, I'm allowing all the sessions, enable this policy, I click on OK. Now we have a policy that says IT guy should be able to talk to the finance guy, right? The service is all, the action is accept. We don't have to NAT it, no inspection. Let's come to the PC and see if IT guy is actually able to talk the finance guy. So I'll come to this PC and I say enter. So it's working fine, right? So that is the whole point of having the uh, zone-based architecture, right? The zone-based policies. And the conclusion here is that every time you have a zone-based policies, right? You create a zone, you put the multiple interfaces in that zone. The default behavior of the FortiGate is that the intra-zone traffic is always blocked. If you want to make sure that the interfaces which are part of the same zone should be able to talk to each other, you go ahead and get into that particular zone and turn that particular button off, which says block intra-zone traffic. That's how the members, the interfaces that are part of that particular zone would be able to talk to each other. Now, this is the case of intrazone, right? Now, if you're talking about the interzone traffic, which means communication between multiple zones, it's only possible when you have a firewall policy in between, making sure that this particular zone actually talks to the other zone, right? Now, I guess that's enough for today. So already have 15 minutes. Any questions on this one, guys, before we close this session?
No question.
All right. Okay, then I'll see you in the next session. Till then, thank you so much for your time. Please take care. Bye.